Hi guys, this is a Calc video 5-6. It's for Tuesday, January 10th. There's going to be no homework that corresponds to this, and this is just going to be very similar to what we did yesterday. It's more practice with rewriting sums and differences and constant multiples of integrals and stuff like that. So, but first we're going to do a little exercise. Using the graph above, estimate the value of each integral. So, here you could see that like this is a piecewise function. It's defined in 3 parts, and there's a gap here between 4 and 6. So the function isn't even defined for those values there. It's also not defined at 9 or even at 12, but it would not be considered a gap. Okay, this is just like a single discontinuity. It really has no dimension there. So this wouldn't be considered a gap. All right, so the integral from 2 to 4 of f of x, this is the area under the curve. It would be the exact area under the curve on this interval, except we don't know, we're not going to find the area exactly, we're just going to estimate it. So, so I'm on this interval, and I want that area for the first one. And all of these, the height of the function here stays pretty much at or around 3. Okay, so this is almost a rectangle. So I'm just going to say that this area is approximately the area of this rectangle, if you imagine straightening that out. So the base is 2, and the height everywhere is pretty much at 3. Okay, so about 6 would be the value of that integral. Now, so using the graph above, estimate the value of each integral. That's what we're doing. So this next one, we want the area from 2 to 7. Okay, the area under the curve from 2 to 7. But the problem is, guys, that in this space here, you would have like an infinite area. Because, well, the graph isn't even defined here, so let me say it that way. Forget the infinite area thing. The graph isn't even defined here, so we can't even begin to think about the area underneath the curve for this gap right here. So anyway, if, so we'll say not defined or undefined. If there is a gap on the interval that you're taking the integral over, then that integral is not defined. Okay, this one here, from 7 to 11. So 7 to 11. 7 to 11. Now, even though we have a discontinuity at 9, this wouldn't be considered a gap. It's just a single jump discontinuity. So we can compute this integral if we split up this area into 2 integrals. So the area under the curve there and the area under the curve there. So I can use the additivity property that we discussed yesterday to split this up into 7 to 11 f of x plus the integral from 11, no, my bad, 7 to 9. Okay, so 7 to 9, and then plus, that would be 9 to 11. Okay, so this integral is approximately the area of that rectangle. Imagine straightening that out. So that would be 2 times 3. So that integral is approximately 6. Plus this integral, we would use that rectangle, 2 times 2. Okay, so that integral is approximately 10. Alrighty, so now we're going to rewrite the sums and differences of the integrals below as a single integral when possible. And if not possible, we will say so. All right, now first of all, guys, I'm sort of going to jump around here. I just had the idea to jump around. And I'm going to first figure out the ones that I can use additivity on. So I'm going to be looking for, and let me flip back for a minute. The additivity property for definite integrals, this is back on page 8, says that if you're adding two integrals of the same function and the upper limit of one of them is the same as the lower limit of the other, then you can express that as one single integral, and then you keep the lower limit and the upper limits of whatever you're working with here in f of x dx. So I'm going to be looking for this form wherever I have a sum of two integrals of the same function, and then I have an upper limit matching a lower limit, then I could use additivity. So, and I recommend that you pause the video right now and try to find them yourself. I think that'd be a good exercise. But if you don't, that's all right. But I think it'd be way more effective if you did that. So I'm recommending right now that you pause the video and look for the ones you could use additivity on. Okay, so pause the video now if you want to do that. Otherwise, I'm just going to move on. So the first one, I have a plus sign, both integrals of g of x, and this upper limit is 3, that lower limit is 3. All right, so I've got a match there. So that means I can express this sum of integrals as a single integral from 1 to 7. All right. And now, guys, if you don't want to use additivity, you could think of it this way. Let me just look at like the x-axis. So let's suppose that's my x-axis. This is an alternative. All right, I've got 1 to 3 and then to 7. All right. If I do the area under the curve so if I do the area under the curve there, and then the area under the curve there, that would be the same as doing the area under the curve on the entire interval. Okay, so that's another way that you could think it through. Alrighty, so this one, can I use additivity on? 1 to 3. Okay, I almost thought I could. Never mind. I said I was going to jump around, but let me not. I'm just going to go right in order. I can't use additivity, and the reason is because that's g of x, that's h of x. All right, so this one is not possible. All right, so each time I'm asking, can I use additivity? Number 6, can I use additivity on that one? Well, I have the same functions. I have the upper limit here and the lower limit there matching, but I can't use additivity because that's not a plus sign. Okay, so I can't use additivity. So, so what can I do? If you're ever confused about what you can do, then you should draw like a number line like this. Okay, so again, we've got 1 to 3 and then to 7. All right, so we have the area, so this first one is the area over that interval. And then we are subtracting from it the area over that interval. So we're having the area on the orange interval minus the area on the pink interval. There's really no way that we can express the difference of these intervals as one single interval. So this is not going to be possible either. I don't even know if that color coding helped, but that is also not possible. Alrighty, so this one. Okay, so same functions, integrals of the same functions. We don't have like an upper limit, lower limit match, and furthermore, this is a minus sign. But if I change this to a plus sign, I could switch these limits of integration. So I would have 1 to 7 g of x plus 3 to 1. And now this lower limit and that upper limit match. So I can use additivity. So this is going to be equal to the single integral. So now like before, guys, it was in like good order like that, like the diagonal was going this way, but it's okay that the diagonal is going like upwards this time. I would just keep, so I'm going to keep the lower limit of 3 and I'm going to keep the upper limit of 7. Okay, and I can do that. And similarly, you could think it through with like a number line like that if you want. Alrighty, so this one. This one is extremely similar. I can't use additivity because I don't have the upper limits and lower an upper limit and lower limit match, and I also don't have a plus sign there. But if I change this to a plus sign, I could switch those integration limits. So 1 to 7 g of x d of x plus 7 to 3. Okay, now we have a match. 1 to 3. The integral from 1 to 3 of g of x. Okay, and that's a nice one to think through with a number line. That'd be a good exercise. Okay, this one, oh, is the same as the other one. Okay, this is basically the other one after we changed it. So this would be, yeah, so those are matching 1 to 3. The integral from 1 to 3 of g of x. This one here, I've got an upper limit, lower limit match. I've got a plus sign, but it's not possible because those are not the same function. So this is not possible. One more. This one here, lower limit, upper limit match, same function, plus sign. So from 3 to 7, the integral from 3 to 7 of g of x dx. All right, guys, so that wasn't too bad. There is no homework that corresponds to this, and I will see you tomorrow. Bye-bye.